Hey folks, Rich here at RCINFORMER. Thanks for checking out this video on the Air Epic Taft Hobby J-10 from Banana Hobby. As you saw from the flying video, it's a great flying airplane. It does not need any kind of a building guide for this thing for the most part. The whole thing goes together with 14 screws. Both the wings just press on, and then there's 2 screws for each wing. You can see the 2 screws, or 4 screws I should say, for the rudder, 2 screws for each of the ventral fins. And then 2 screws that actually put the canards in place. And then you glue the tail cone and you glue the nose cone on and a couple of antennas. And then this thing's ready to put your receiver in and go, guys. So not really a whole lot of building to do. However, there have been a lot of misconceptions about the center of gravity on this airplane and just general setup information. And then when I put mine together, there's a few little tweaks and things I did. I routed some wires differently. I have a good technique for putting the tail cone on a little bit differently than they suggest. And all the setup items that you're going to see in this video is everything I did to the plane to get it to fly well. So from the flying video that you probably saw, and I'll put the link at the end, this video is going to detail all those things I did and make sure that you guys are setting this thing up right so you have real good success when you get out there flying it. Anyway, let's get on with the video, and I'll show you how to set this J-10 up for flight. The first item I want to cover with the J-10 is the center of gravity, because it really is the most important thing with this airplane. Now, to cut right to the chase, the center of gravity on this plane is right here. Okay, right where this panel line meets the leading edge, okay, is exactly where this plane should balance, and it flies fantastic right here. Now, there have been a lot of people that have had disastrous consequences with this airplane, and it's gotten a bad rap, I think, solely because of this picture right here. Now, this is the CG picture that we've all seen online, and it's changed actually several times. And even in its form, it's half wrong and it's half right. The part that's correct is right here, where they draw this line, and you see that the CG actually lines up. The CG line lines up with this panel line right here. That is the correct position for the CG. But if you measure that forward to this point right here, which they outline as this little thing right here, you don't get really 140 millimeters. You get more like 170, okay, back from this point. Now, you'll notice that this side of the picture, the right side of the airplane, and the left side of the airplane in the picture are actually different. You can see they put this line right here on this side, this red line here, and there isn't one on this side. Well, what this red line represents is where the wing actually connects to the fuselage. Now, if you take a look at this picture right here, I'll flip it upside down so you can kind of see this. You can see this little sort of rectangular / triangle point right here. This little spot where it tells you to measure the 140 from is actually this spot right here, and I think this is what everybody's misconstruing as the place to measure. So if you measure 140 millimeters back from here, you get to a point that's about in here somewhere. Okay, so it doesn't quite get to the actual center of gravity, so the CG is way too far forward if you measure 140 from here. If you go 170 back from here, roughly, you'll get to this point and so forth. But you really want to be measuring the 140 from actually this point, which is actually where the wing actually contacts, and that takes you right back to here. So whichever way you want to look at it, or 170 millimeters from this point back to here, or around 140 from here back to here, in either case, the CG, the correct CG where it flies well, is right on this panel line here, right where it meets the leading edge. So again, keep in mind, you know, the picture was a little ambiguous, and I think this is what was really throwing people off. And just to show you on the underside of my wing here, you can see where my CG mark is right here. And if I take my ruler right here and I line it up here with the leading edge, right there, you'll see that's where 140 millimeters lines right up. And also you can see 140 lines directly up with this, pretty much with this panel line. So, you know, as long as you get this CG marked, and you see it lines right up there, as long as you get it lined up with this panel line right here, you're going to have a dead-on CG on this point that'll make this fly perfectly, just like you saw in my flying video. Now when it comes to balancing the J-10, the battery that you guys use is just super critical. And depending on the battery that you do use, and you can see right here, using these Genesis Power 65C 5000s, and I'm using the 6000s. But you have to remember there's a tremendous weight difference, and the battery that you choose to fly in this thing is going to make a big difference in the CG. Now the smaller 5000 weighs in at about 1.7 pounds, 1.8 pounds. The big one weighs about 2.1 pounds. So you know, the difference in ounces, you know, grams, it's about 150 or so, and ounces, it's about a 4 or 5 ounce difference in the two of these. So you also have to look at the airplane and say to yourself, okay, way up front here where the battery is, I'm putting a ton of weight, and look how far it is away from the CG. So if I change the weight and put a heavier battery up front by 4 ounces or 5 ounces, I got to put 4 or 5 ounces back here somewhere to counterbalance it. Now, the airplane is designed for a 5000, so if you guys are using a 5000, you can almost balance this thing as is with this plane, and you don't really have to do much to it. One thing to consider, in the tail compartment of the airplane right here, they intended for this area back here, I think, to be like a future drag chute or smoke system or something. I'm not sure, because there is a wire back here that goes back here for a function that's to be used later in the airplane. So, but what I did is, and what I found is when I took this little cap off, and you can kind of see what this thing looks like right here, it was just very lightly glued on. I found bobbling around inside here was this counterweight right here. Okay, it's just literally just a steel weight that they stuck in here, and you can see how I labeled mine. I labeled my front with a 5,000 milliamp pack, because what I found out is that with this weight in here, all the way far forward, okay, with the 5,000 milliamp pack, it balanced perfectly on the center of gravity, and it flew great. I wanted to make this interchangeable, because if I use a heavier battery up front, I need more weight back here in the tail. So what I did was I created this piece right here, guys, with a pin, okay, that goes through. I just put a piece of push rod. So, you know, I can push that through there and lock that in place. So anytime I want to change that tail weight, or anytime I want to change the battery, I have to change the tail weight as well. So I just put this cap on here, and you can see I can just push that through, and it'll lock that into position so it won't go anywhere. Now the reason you need this foam block on here is to keep the weight from sliding around, because as you can see, this big weight right here was literally sitting inside this tail cone, and it was just moving forward and back in the box. So you can't have that during flight. That thing needs to be fixed. So again, the formula that I found out that worked well for me, and it may be a little different for you, is with the 5,000 milliamp battery that you see right here. I put this bit of tail weight with this foam and block in there to keep it from moving around. If I move up to the larger battery that you see right here, okay, again, 6,000 milliamps, 2.1 pounds, about 5 ounces, you know, heavier. I needed more tail weight, but I needed it shifted to the back. So again, you can see I took all these wheel weights, guys. This is from Harbor Freight Tools. Just a bunch of weights I taped together, and just a little chunk of foam right there to keep it from moving around. And I found by putting this battery now up front and putting this one in the tail cone back here, I was able to balance it out, again, to balance right on this mark. So you've got to really consider the battery that you're using, and once you put your battery in there, put the proper weight that you need, how much or how little you need back here, and get it fixed in position with a piece of foam like that. And again, you can use this pin just to very carefully lock this tail piece in place. And once you get the amount of weight that you need with some trial and error, balance it right on that point, it'll fly perfectly every time. So it's a good idea to use the same batteries for the airplane, but if you end up using different ones like I use, just make sure that you have the correct weight for the size battery. And again, this smaller weight for the smaller battery, and I needed the larger weight for the larger battery, which is in there now, and you may need to switch those around. But that's essentially how you balance this thing, is just make sure it always balances on this mark regardless of where your battery is. Now with your battery up front, you want to make sure there is a stopper back here that you push the battery back and the battery stops at a certain place. There's a little bulkhead here. You always want to make sure that battery is in the same position every single time. If you put a little farther forward, it's going to change the CG, okay? It can't go any farther back because the stopper is there, and the hinge point here for the really nice aluminum torque rod for these canards is here, so it can't go back any further. But you want to make sure that's all the way up against that block, okay, and secured in place in the same position every single time. Here's a quick look inside the battery compartment to show you a couple things. I'm going to mostly show you that stopper back here, but while I'm in here, just to show you a few things, this thing has a really nice spark arrestor. So you connect your negative wire first, you plug in your positive wire next, and you get no spark because the capacitor that they designed into here absorbs that spark. And then you go ahead and you connect this connection right here, and now the thing is together with no spark. So really nice design that Taft did with this thing. But what I wanted to show you in here was a couple things. Notice I have the battery straps here. I put a second strap in here. They only gave you one, but as you can see, I put a second one in here, and I'm going to go ahead and try and get those off for you so you can see inside here. A couple things I did, as you can see down here, I put shelf liner down here. This plane didn't need Velcro. You can use Velcro if you want to. I just thought it was overkill. The shelf liner is nice because it keeps the battery stuck in place from shifting around, and you don't have to tear the thing out with Velcro. It'll keep it in there nice and tight. So I put some double-sided Scotch tape. If you guys have seen my videos, you know how I do that. Put double-sided Scotch tape along here, and I put that shelf liner down there, and that keeps the battery from sliding around, and I can get it out in and out easily very nicely. So you can see back here, what I'm really pointing to right back here, guys, is this stopper here, okay? Now, for the CG purposes, you do want to make sure that when your battery gets mounted there, that you push that thing, the battery, all the way against that stopper every single time. Make sure the battery's in the same spot. Again, if you're a few millimeters forward, you know, half an inch forward of that stopper, you will affect the CG of this plane. The CG will be farther forward, really, than it should be. So, one other thing to keep in mind: you see your really nice aluminum torque rod for your canards. The battery has to stop at this point, guys. If it goes back any further, it could impede with the rotation of this canard. So, what I did, mine was a little loose, so I ran some CA along here, made sure that this thing was really glued in place, so my battery didn't end up sliding back any further, and again, stopping this thing from rotate. But again, the biggest point I want to make is to make sure that when you mount your battery, push it all the way back so it's in the same position and it's contacting that bulkhead every single time, and then strap it down tight, and you'll be assured that you have the same CG every time you fly. Now, before setting your center of gravity in the airplane, as I just showed you, and the reason I showed you guys that first was because it's like the most important thing to make this thing fly well. But before you set the CG, you've got to get everything in the airplane all set and straightened out where it's supposed to be. Now, one thing that I found with this plane was that the wires here for the ESC, and you can see the ESC back there, it's a 120 amp controller. It was not really secured to anything. It was just sitting in there in the middle. It was just sort of flopping around, and right in front of this 105 millimeter fan right here, folks. So, and you can see how secure it is now, but it wasn't that way when I got it. It was actually way down there. It was running through the center of that hole, and you can kind of see down in there this thing goes, but it was running right through the middle when in reality there's actually a channel back here. It's kind of hard to see from this angle. I'll show it to you from the inside, but there's a channel where all the wires can go through here instead of going through the middle of the whole fuselage forward. So what I did is I put a couple of tie wraps right here, and also on this edge of the fan, this little lip right here, on the inside edge. This is kind of tough to see, but I actually sanded down the inside portion because this inside thing is really sharp. So I just rounded and beveled the edge. I'll see if I can zoom in on there. That's kind of hard to get, but I beveled that edge there, so these wires coming around here, right around this angle here, the insulation doesn't get damaged by this sharp edge. This is a 105 millimeter change sun fan, so it's made out of a glass reinforced plastic, and it's kind of sharp. So you round these edges, it'll really protect these wires coming around. I put 2 tie wraps here, and then to really secure this thing, a tie wrap right here to hold these wires in place and keep them away from from this fan right here. Now, if you also follow this up, you see this is the carbon spar for the wing. It only sticks out about 65 millimeters on each side. But what I did is I tie wrapped the main wires to that spar running through. Again, to keep that thing from flopping around because it was just loose in there. So if you put a tie wrap here, and again, I had to cut these two holes here with a drill and a hobby knife here and here, and I put this black tie wrap right around it. It actually zip ties on the other side here. But now this whole thing's nice and secure. It's secured with a big zip tie here, and it doesn't really move around much, and the wires go through that channel on the underside. If you do this and secure this in position, this thing will be locked in place so it can't get pulled into the fan, and it's here for plenty of cooling as well. Now, when you throw this thing into reverse thrust, the fan starts spinning the other way, and it actually blows the air out of this hole, and it blows it out, down, and forward. So you will block up the hole a little bit by having the ESC here, but the ESC is going to get plenty of cooling, and it's going to be nicely secured in position. And I have found that securing it in my plane this way has worked tremendous. So it's a good idea to keep that thing, do something to it to tie it down here and here, so it's not free floating in there. Now, with the airplane flipped over, I can show you the remainder of the wiring, and this is the mid compartment that really gets you into the most of the electronics. And you pull this lever back, and this opens up. Super nice design on this thing. Probably one of the best hatches I've seen. Both the front and back hatch are really nice on this model. You can see all the electronics in here, and the electronics in this plane are extremely good. They're really good quality. You can see here the canard servo that operates the really nice aluminum bell crank and canard unit back there, and all the other modules are in here. Now, the quality of the wiring is pretty stellar in this plane, but what I found was when I got it is all the wires were just sort of bundled up in here. Now, the intake through the front of the airplane, it pulls it in through the scoop, and all the air goes blasting through here. And what I found is just all the wires were in the middle. The BEC was just sort of hanging loose in the middle. The ESC wires that you can see coming up, the power wires and everything, through that channel that we just talked about on the underside, they weren't coming through that channel. They were kind of coming through the middle here. So if your plane, I have an early sample of the plane here, guys, so if yours is not running through that lower channel, it should be. So you may need to reroute those ESC wires and your BEC, which you can clearly see your BEC right there. They should be coming through that lower channel, not through the middle here, where the fan can just pull all that stuff in. Now, as I indicated, all the wires were just floating around in here, and I secured everything to the sidewalls. And you can see right here, two big black tie wraps to secure everything here. I used a tie wrap or so right there. And then on the opposite side, same thing. I ran the power wires up this side. You don't have to do it this way, but these are just a couple ideas of how to do it. You can see this black tie wrap right here that I did to secure the big wires. And this tie wrap, this single black tie wrap on this side, and those twin tie wraps right there actually go down into the landing gear bays. Okay, and where I put a piece of wood and secured them. I'll show you that here in a future clip so you can see what those look like. But I had to do something to secure those things, and that's how I did it. Was I went through the landing gear wells that were right there. And then with all these other green tie wraps, I tie wrapped all this stuff in place to keep all this stuff secure, because again, all the air is blowing past here, like right underneath this tray. And with if all these wires are sitting here in the middle and not like pushed to this side and kind of pushed to this side, those things potentially will wiggle and shake and get pulled back in there. Who knows you know, where they would go. But that's basically how I secured this thing, was by all these tie wraps and those large black tie wraps, again, that go down into the landing gear wells, which again I'll show you here in the future. You could see the yellow wire here, which actually this yellow, I put some heat shrink wrap around this. These are the wires that come from the rudder, because the rudder you feed through here and it runs through here, and then all those come here. So I secured that and again pushed that to the side to get it out of the way. And you can see here how there's a nice, pretty clean path back here now that actually goes all the way back to the fan. And whereas before, all those wires were just sort of running in the middle. So make sure that the plane that you get, you're utilizing that channel down there to run all of your wires. Now here's another view from the front of the airplane, and one thing I wanted to point out here was that you've got these really sweet like formation fuselage lights on this side and on this side of the plane right here. But the problem I found was that the wires that run to them here and the wires on this side were literally soldered here, and then they just went straight back into the scoop. They literally were free running back in there. Well, you can see the fan all the way back there, guys. That thing is going to be pulling through this intake, and those wires are going to be flapping around and shaking, and it's probably not going to take more than a minute or so, or even less, for these solder joints to break and those wires go all the way back into there. So you can see here on the side that it appears that they ran a channel up the side here that they intended to secure those wires with. You could see it a little more clearly on this side. You see that channel that runs up. Now, I didn't use the channel on this side because the PC board, the wires kind of came out of the back side. So I took some hinge tape, 3M blender, and I ran it up along this and just ran that wire up kind of diagonally. Whereas this one here, I did run all the way up sort of inside the channel it was intended. You do want to be careful using tape on the inside of the scoop, because remember, the scoop is a vacuum cleaner, and if it grabs a hold of that tape can go back into the fan too. So now, so far, my Blenderm tape job here has done a good job. It's not coming off or anything, but you want to kind of frequently sort of inspect that tape if you put tape there to make sure it's not peeling off and make it sucked into the fan. So good idea to secure those wires and these wires here. Now, a couple other things to notice as you look way down into here. As we just saw from the top side, you see the BEC there, you see the wires running up and down from the landing gear right there, and then you see the other side power wires coming from there. You can see the black tie wrap there and the two black tie wraps there that I went into the landing gear wells to secure all that with. You can see there's a relative straight shot here now for the fan, and the fan gets good air now, but it's got to blow by all those wires, okay, to get to the fan first, and this is where all the air comes from. When I first got this airplane, all the wires were right here in the middle. I couldn't even see the fan, okay? So all those green tie wraps, all the securing of the front wires, the back wires, all to the side. See, I pushed them to this side, pushed them to this side, secured them with tie wraps, and taped them. And that gets everything out of the way, so now there's a free, clean shot back to that fan. So the quality of the wiring is good. It's wired correctly. It's just that it needs to be routed a little better. And what you're looking at right here is after I've done the flying videos, guys. So I've been flying it this way, and it works beautifully this way. But it's a good idea to secure all your wires, guys, in a similar fashion, okay, on the inside of this thing to make sure that the air blowing by them doesn't grab a hold of them and pull them in. Now, as we take one more look into the scoop, at the bottom of the servo tray and all the electronics, you can also see that in addition, I put a bunch of tie wraps and ran my power wires under this tray. You can see that tie wrap right there that secures it. You can see also right there tie wraps that secure it in place. If you run your wires underneath like I did, you notice all those screw heads sticking out. The screw heads that may interfere with that insulation, I went ahead and flattened them. I just backed the screw out of the top of the plane, which you can see the electronics bay right there, all those screwed in things. I would back out the screw and then with a Dremel tool flatten the head of it. And when I flatten the head, you can see here easily that with flattened head screws, it's not going to interfere with the insulation. So again, it's just something to be aware of running your wires underneath here the way I did, that you make sure that those screw heads are not going to interfere and tear up the wire insulation. Now with the airplane flipped upside down, I'm going to show you here where I secured the BEC. You saw the BEC on the inside electronics bay secured to the sidewall, and you can see I utilized the inside of the landing gear well to put a little block of wood here, and then that's where the tie wraps go to secure that BEC. There's plenty of room in here. The wheels clear it very easily, and it keeps those in place. Same thing on the other side. You can see a very small block of wood with a tie wrap to secure the main power wires, as we just saw on the inside there of the electronics bay. So just a couple ideas. You don't have to do it this way, but it has worked perfectly for me this way. Now, a couple other things to note. You can see I put a little piece of Gorilla Tape right there to secure the gear door servo wire there and right here, so it helps to kind of put a little bit of tape to secure that stuff. The other thing I noticed too is that every time the landing gear went up and down, okay, the wheel would strike this little rib. And this rib, actually, if you can see carefully, it used to extend to about right here, and it looked like this piece right here. You see where it has a sharp corner. Well, it went to about here, and it had a sharp corner. And that wheel, every time it would go past, it would strike that. So you can see I took about ½ an inch to about an inch maybe off of that with a Dremel tool and just sort of sanded it round. So now when the wheel goes in, it rotates this way, and it very carefully brushes by this, and it doesn't snag on that corner anymore. So if you have that problem with your plane, just sand it away with a Dremel or something, and that will take care of it. A couple other things with the landing gear. Actually, you can see how sweet this gear is. Really nice aluminum with really nice metal sliders down in there. This is probably some of the finest landing gear I think I've seen on a plane. And as you saw in the flying video, this thing will take some abuse as well. So it's some tough stuff, and it has functioned flawlessly for me thus far. One other sort of tip, suggestion that I would say to do to these things as well is I would, like I do with a lot of my other airplanes, I would run some contact cement, like you can see here on the E-rings. There's E-ring here, and an E-ring right here, and that helps keep that E-ring in place from falling off, because there's a lot of E-rings on this gear. One other thing I noticed too that I really actually couldn't do anything about, if you guys have seen my videos, you know that I do this a lot. This screw going up and down is a threaded screw right here that goes up and down, this one right here, and it kind of tears up that channel. I think it's a 2.5 millimeter screw, and I tried to find one that was non-threaded to put in there, but I couldn't find one. If you can find a non-threaded, like a shank that has a non-threaded half to the screw, it's a good idea to put it in there and have the non-threaded portion go out of there so that doesn't wear out. But I wasn't able to find something like that, and that starts causing play in the wheel after time. So as soon as I can find one that size, in fact, if anybody finds one like that, a 2.5 millimeter screw with a non-threaded shank, let me know where to get them, and I'll post it up here, because I need something like that for this gear. But they do function perfectly. There's not really a problem with them. Other than that, that is one thing I would definitely upgrade. Another thing to note about the main wheels on this thing is they are ball bearing supported, folks. These are some of the nicest spinning wheels I've seen in a while on a jet. But that pretty much concludes here the wheel well section of this plane. While I have the airplane flipped upside down, there's a few suggestions I have for the nose section here. First of all, this little plastic piece right here, you can see this clear kind of Lexan plastic deal here. This thing is designed to kind of go along these little metal sliders here and keep the nose door from binding up in this whole mechanism. And what I found with mine is mine was really loose. It just wasn't glued on very well. So I just had to re-glue it. It's not a big deal. You know, if you find yours is loose, just peel it off. I use contact cement just to glue it in place. And you can see I actually rounded the corners of it just to make it look a little nicer too. But I just had to re-glue it in place again because they just didn't use enough glue. That might have been a one-time deal on my plane. But just something to consider. Also, the insulation on these wires was really kind of bad. And these two wires were soldered so close together, I was thinking they were going to cause a short. So I desoldered and resoldered the landing light and put some heat shrink around them to get these things apart. So just keep in mind, if yours, they might have been a one-time deal on mine also, but if they do a bad solder job, just keep in contact. Just keep in mind you may want to like resolder those if they're too close together, put some insulation to prevent a short. Now, another place I found that potentially could cause a short is this runner setter mechanism plate right here. It's really nice. It works great, but it's metal, and you can see the wires run right underneath that thing, and it holds it in place. You can see how this whole mechanism kind of sits here. But what I did is, you can see right down there, I unscrewed it, and then I wrapped some, you see way down in there, some electrical tape around it, just to protect the insulation a little better so this thing doesn't bite into the insulation. But so far, this landing gear has worked flawlessly right out of the box, guys. The main and the nose wheel has worked perfectly. Now here's one other opportunity just to sort of look down in there at the underside of the electronics bay, and you can see all the tie wraps I used to secure everything. You can see the main power wires right there. You can see where they run up front here to the battery. And then if we go down into this corner, you might be able to see, let's see, you can kind of see way back in there where they sort of tie wrap to everything there. The reason I did all this was because, remember, there's airflow coming in through the scoop, okay, right to here. In fact, you can see my hand right here through here. All the air comes blowing by here full speed past all those wires and then all the way back to the fan. So I very carefully made sure everything was secured to that thing and to the sides as best as I could. And also here's another view of, you can see some of the screw heads down and they're sticking up, and you can see a couple places like right there where I flattened them. Anywhere where they might contact the wires, you want to make sure that you don't have any screw heads sticking down there that could tear into that insulation. But anyway, for the most part, guys, this landing gear system is really awesome. It's worked great for me out of the box, and these are just, like I just showed you, a few tweaks that you can do to it to really just to make sure it's going to work well for you. When it comes to setting up your radio in the J-10, it's really only a 5-channel airplane, really. It is elevator control here, up and down, and it's aileron control. You can see here right and left, just the wing ailerons, your rudder, and of course your throttle, and your retractable landing gear. So it's a 5-channel airplane. You can get away with flying it just like that. Now there are 4 special features, and I'm going to show you those right here. I'm going to go ahead and put my high rate on so I can show you. There is a switch that you can assign here, that you can flip the switch, and what it does is it turns your canards off. So you only have elevators on the wings and ailerons. So that's an on-off sort of feature for the canards. There's also a canard gain. Okay, so you can adjust the travel, okay, of your canard for more aggressive maneuvering. So you can see how much that moves. They recommend putting it onto a knob, and you can put it on a knob or a side slider if you have it and you want it that way, or you can put it on a switch like I did. They recommend the knob, but honestly, if I'm going to do aggressive maneuvers, I want it full or nothing. So I just went ahead and put it on a switch because it's on the Futaba. It's actually easier, much easier to reach the switch than it is to kind of turn the knob. And you may put it in an intermediate position and you don't know where it is or whatever. So I just have it all a full or back to normal. So you can see how you have all of that travel there for some aggressive vertical maneuvers. Now, the last 2 functions, one of the last ones is an air braking function, and I hooked that up to this switch right here. You want to make sure you put it in a place where you're not going to flip this during flight, because you will have some problems if you flip that during flight. As I flip that switch, you can see it gives you full canard travel and opposite ailerons and elevators for aerodynamic braking. So when you land on the runway, you flip this out at as high of a speed as you can. That'll help slow the airplane down because it creates a lot of drag. And then finally, and you flip that switch again to put them down. And finally, there's the reverse thrust feature. So, and you can hook that up to any switch you want to. They have you put it on a separate switch, but honestly, I put it on the same one as the reverser because I figure if I want to stop, I want everything out. So I Y-harnessed it into the reverse switch, and as soon as I flip this switch and I get the aerodynamic braking feature, my motor polarity is now reversed. Okay, so now I have reverse thrust, and all you have to do is advance the throttle to get that reverse thrust. Now, what I'm going to do is give you sort of a little demo here. We're in regular thrust. I got some batteries securing the plane so it doesn't roll off the table here. I'll give you a little bit of throttle here. I'll hit the reverse switch, and you see it automatically puts your air brakes on, and it will automatically take your motor and it'll stop it, and then it'll reverse it and spin it the other way. And again, you're okay to do that while you have the throttle on. You just flip that switch, you get the aerodynamic braking, and then the throttle reverses. And the air will actually come out of the bottom through the louvers and go forward and help you slow the airplane down. Now, usually when you land, you're at idle anyway, so normally what happens is you land, you're pretty much just at idle, you flip the switch, and then to get your reverse thrust, you just advance your throttle, and you can see that it just blows the air forward. So really neat feature. Now let me show you the inside electronics bay there, and I'll show you how kind of easy this thing is to wire up. As we look inside the airplane, I'm going to show you the basic features and then sort of the advanced functions of the plane. Now, this PC board right here is pretty much the heart of all of the mixing. You don't have to use Delta mixing or anything on your radio. All these connections are already made for you. They all come from the wings and the elevators and everything. And this board, these lines here plug right into your receiver, and all the mixing, again, is done for you through this board. Now, these two lines on the side here, the black, red, and white, black, red, and white, those go straight into channels. It's simple. They just go into channels 1 and 2 for your aileron and elevator, and then your canard mixing, your elevator and ailerons on the wings, everything is already mixed. You don't have to do anything. That's the beauty of this plane. Your other channels, your throttle line, number 3, that comes in off the BEC, and you can see how that is plugged in right there, and that all goes down, you know, towards where the BEC and the ESC are. So, and then channel 4 comes from the rudder. Now you see the rudder line coming in from here. The rudder line, for whatever reason, comes in through here, and then it goes into this little hub right here, and then it's all labeled well, and then this hub, this line goes there into channel 4. And then 5 simply comes from the retract board, which actually that runs from over here, and it just kind of runs in here, and that's it. You have channels 1, 2, 3, 4, 5. It's very simple for these basic functions, and everything is already labeled for you to go in there. Now, once you have your first 5 basic channels connected, which is your aileron, your elevator, throttle, rudder, and gear, you have 4 functions left, and if you have an 8-channel radio like me, they'll all fit onto these 3 channels, because I Y-harness them into the reverse and the aero braking function into the same one. But the connections are as follows, and it really is pretty simple. You can see by, again, this mixing PC board, there's really only 3 wires here. Or here's the 4 wires, I should say. There's the black, the red, the orange, and then there's the yellow. That actually, this yellow line comes off the BEC. That's the reverse line. But what I did with mine is I took the red wire that comes off the mixing board here, and I plugged it into channel 6. That red wire very simply just turns the canard on and off. So you can flip that on any switch to allow that canard to come on and off. The next one I plugged in, and I'm going to skip over to actually to 8, and you can plug these into any channel you want. The 8th channel, you can see here I plugged in the orange wire, and you can see that orange wire comes right off of here. That orange wire is to adjust the gain, so you want to put that on something that you can assign to either a knob or a switch, so you can adjust the deflection of the canard as you wish for flight. Again, these are not necessary functions, but you can hook them up. The black line here, okay, will go into an open channel, and the black line is for the, as it's labeled here, for the brake channel. That's the aerodynamic braking, okay? And that'll go into any open channel for a switch, and so will the yellow one, okay? So the yellow one will go into any open channel, okay? And when you flip that switch, it reverses the polarity of the fan. So what I did is I took the black and the yellow, as you can see right here. I plugged them both really into a Y-harness. So you can see the black and the yellow, try not to make this too confusing, plugged into here, into this Y-harness. And then the Y-harness swings around and goes right into channel 7. And then that channel 7 I assigned to one switch. So when I flip that switch, I get the aerodynamic braking function, and it reverses the polarity of the fan. And it's really that simple to wire this thing up, guys. Very, very simple. Again, aileron, elevator, throttle, rudder, landing gear, and then again my 6th channel is to turn the canard on and off. My 7th is reverse thrust and aero braking, which you can split into separate switches if you want, but I put it into one. And then the last, the orange channel, is for the gain control, or the adjustment of the canard to give yourself more or less throw. And it's really this simple to set up, guys. One more item concerning the reverse thrust. In order to get the reversed thrust to work, I had plugged mine in initially and it just wouldn't work. You have to use a programming card of some kind to program it. Now, it's really easy to do. I use this Turnigy programming card, but as you can see here, there's a Hobby Wing one, and they're identical. Okay, there's really no big difference in them. You literally just plug your BEC in here, apply some power, and then you just change the parameters that you want to. So, but to get the reverse thrust to work, you have to have your brake on, okay, the braking feature on, and you have to have the governor mode on. Now, on the Hobby Wing controller, they call it like brake on or off, but it's governor mode. It's really the same thing. So if you have a Turnigy programming card like this, I got this from my Plush controllers years ago, it works just as well. So brake on, governor mode on, you program it that way, and your reverse thrust will work perfectly. One thing I did to my airplane to make the front end of this thing a little more secure, as you can see here as I move this nose cone, the whole thing kind of flexes a little bit. The intake scoop here is not really glued or attached to the upper part of the fuselage. Now, I knew I was going to do a little inverted flying with this, and you put a 2-pound battery like right here in the fuselage. So I figured flying upside down, I really would like this a little more secure. So what I did to fix that, and this is something you don't have to do, is I took a screw, like a washer head screw here, and I drilled it right through here up into the battery compartment and secured it with a block of wood and a blind nut on the top side of the airplane. So that really helps tie the top and the bottom part of the fuselage to scoop together, and makes it quite a bit more secure. So let's take a look at exactly what that looks like. You can see here from the underside where I put the washer head screw. It's just right in the scoop here, and I just drilled a little hole and put that thing all the way through. It's I think it's a 3mm screw, and as we go through to the top side here, you can see where I made this little wood sort of bulkhead and this blind nut right here. So that helps distribute the load, and again it ties the top and the bottom together and makes the whole nose section much stiffer. You can see now that after adding just a single screw, trying to pull up and down on this, you can't even move it anymore, and it's really tough and really secure. So it really makes a difference. Just adding that one screw right here, tying that top and bottom together, just makes a much more secure nose for this airplane. When it comes to gluing on the tail cone on this airplane, there was sort of a last-minute change at the factory. They found out that with a slight bit of upthrust in the nozzle, the plane actually flies a little bit better. It's probably so you don't have to have so much, up canard travel, and the plane probably settles into a high alpha better or something. But what they have you do, according to this picture I'm going to throw up here, is leave a gap at the bottom of 7mm, as you see in this picture again, and no gap here at the top, and that angles the nozzle up. It gives you a little upthrust. But I found a little better way to do it. What I did with mine, what I thought was cleaner, is I shaved 7mm off this top lip, okay? 3.5 right on the sides, 0 at the bottom. So the whole thing fits on better. It still angles up 7mm with a slight upthrust. Only you don't have this nasty gap, and you don't lose your gluing surface on the bottom, and it looks nice and clean like this. Best of all, I've already done all the flying videos on this thing, guys, so the plane flies great, just like this, and it looks really good. Now, I filmed this clip before I glued it on because obviously I can't unglue it and show it to you, so this clip is a little out of context, but it's going to show you exactly how to mount this thing the way that I did it if you want to do it that way, and it really turns out quite nice. So here's that clip. One of the things that they have you change with the tail cone is to add a little bit of upthrust to it, and what they do is they give you this instruction guide here, and when I was setting mine up, you can see on the underside of the airplane, not a real great picture here, but here's the tail cone right here, here's the underside of the plane, but they have you measure 7mm, okay, and here, and leave basically a 7mm gap here, and what that's going to do to the nozzle of the plane is sort of angle the nozzle up a little bit. Obviously there were some issues flying the plane of some kind, so they wanted a little upthrust in the nozzle. Now, in order to do that, what they have you do really is kind of put your nozzle on and then just kind of angle it up a little bit and leave a 7mm gap all the way at the very bottom of the airplane. Now, rather than do that to mine, I decided to do mine a little bit differently. And you can see here, this is sort of a sample of how I did mine. And essentially, instead of angling it up and leaving a small amount of glue space here at the bottom, what I did is I took 7mm off the top right here, and very carefully with a hobby knife, you can see all the shavings, I took a hobby knife and very carefully shaved there, and I marked 7 millimeters at the top and very carefully cut it down here. I marked 3.5 millimeters here, and just very carefully with a hobby knife cut this away. And you can see what the scrap piece here looks like. It's just a little piece that I cut off. And what that does is that's still going to angle the nose, or angle the cone upward a little bit and give you that little bit of up thrust. But it's not going to leave a big gap now under the bottom, and it's not going to reduce the gluing surface here on the underside. And you can see how nicely mine fit. Now, something else to note too is you've got these 4 little vertical kind of surfaces right here that help keep this cone, that are molded into the cone. And what you want to do is put one of those towards the top, and you can see how in mine all I had to do here was cut a notch here, very little notch at the bottom. You really don't need much at the bottom, but this is a 3.5 millimeter notch here, 3.5 millimeter on this side, and then about a 7 millimeter notch there. And what this does is if you do it this way, it leaves you a whole lot of gluing surface here and not really hardly any gap here at all, depending on how good of a job of cutting that you do with this thing. Now, as you can see here, if you do this thing right, this thing will really fit on, really pretty spectacular. And again, instead of leaving a 7.5 millimeter gap at the top, now there's really no gap going all the way around if you do a good job cutting. So foam is relatively easy to cut, and again, just by cutting 7 millimeters off of this, the thing fits beautifully, and it's now up thrusted just the way that they want it from the factory. Now, one other thing you do have to cut is there is this little flange on the inside where you can see where this inside edge is going to hit mostly at the top. So again, you're going to cut 7 millimeters of that away at the top and then run across here. They're going to be about 3.5 millimeters here and then 0 at the bottom. So again, it's just a slight taper of the outside edge here. It's a slight taper of the inside edge. And then just adding really 2 3.5 millimeter notches here and a 7 millimeter notch here, again, to accept these little vertical pieces of plastic here. And then this baby just fits on nice, guys. Now, for whatever reason, they had issues with this, flying it and so forth. And this is the sample model, and I decided to make this video for everybody just in case the production version had the same problem and they wanted an up thrust. And everybody wanted maybe an alternate way to do this, because mine turned out really beautifully this way. And if you've seen this video, then I've already flown it and this thing's flying great, and the flight demo's probably already out there. So anyway, guys, this is just a real clean way to give you that little extra up thrust, that 7 millimeter up thrust in the cone. It's just another way to do it that really works out nice and clean. All right, guys, that concludes this video on the setup guide for the Air Epic Taft Hobby J-10 from Banana Hobby. It's just a stellar airplane, as you saw from the flying video. And hopefully this video will help you get the whole thing together. This is everything I did to my plane. As you see in the flying video, it flies great. I just want to summarize something, though, that I mentioned in the beginning. The CG here, guys, that red line right here is the correct CG. And you want it right on that intersecting mark there, which, again, on the wing, folks, is right here, right at this spot here. And that represents 140 millimeters from right here all the way back, as you can clearly see from the CG sticker that I put on there. The plane will fly great there. Now, I showed you that first, okay, because it was the most important thing on this airplane to get it to fly right. But it's actually the last thing that you want to do. So the entire airplane, everything you just saw in this video, okay, you want to get everything assembled on the airplane first, get your ESC wires and everything secured back here. You saw how I did it. Run the wires up here, secure all these wires, secure all these wires, get your battery in place where you want it, get your nose and tail cone glued on, and then once everything's together and it's ready for flight, then set your CG, okay, and make sure that this thing is set up right. You do that by putting your battery in first, whatever battery you're going to use, and then adjust your tail weight and lock it in position. Use as much or as little as you need to balance it right on that point. And then the thing is ready to fly. You want to make sure you don't set your CG before things are arranged in the airplane and then move things around or adjust wires, because then you change your CG. So get it all secure, put your battery in, fix your weight to your battery, use how much or little you need, balance it on that point once again, and you will be good to go. Anyway, guys, thanks for checking out this video. Check out the plane at Banana Hobby. Thanks for watching RC Informer. And as always, we'll see you next time.